Okay, exercise 8.2, problem 16, discussion. So let's read the problem. Find the mass of 200 steel spherical ball bearings, each of which has radius 0.7 centimeter, given that the density of steel is 7.95 grams per centimeter cube. Mass equal to volume into density. Let's mark what is given in the problem. 200 spherical balls. You are asked to find the mass of 200 steel spherical balls. 200. Number of balls is 200. The shape is sphere. The radius is 0.7 centimeter. The density is 7.95. Anything else? I guess that's it. So radius is 0.7 centimeter. Density is 7.95, and the number of spherical balls is 200. Okay, great. What are we asked to calculate? We are asked to find the mass. We are asked to find the mass of 200 spherical balls. Great. What's the formula? Let's list out the formula. Formula: mass equal to total volume into density. It's already given here. Mass is volume into density, but only thing we are writing it as total volume because we have 200 spherical balls. Okay. So mass is total volume into density. But if you look at this, we will not be able to use this formula as of now because there are two unknowns. Total volume is what we don't know. Similarly, mass is also not known. That's what we are asked to find. So there are two unknowns in this equation, which means we cannot calculate as of now. So we have to find total volume. Write the formula for total volume. Total volume is volume into number. Okay. Again, this also cannot be used because we don't know the volume. Right. Come to the next step. Volume of one sphere is 4 by 3 pi r cube. Yes, this is fine. We should be able to calculate because there is only one unknown volume and r is known, so we can use this formula. So substitute r equal to 0.7 and calculate volume. Once we know the volume, that volume into number, which is 200, will give you total volume. Then the total volume into density, which is 7.95, you will be able to get the mass. Okay. As usual, when you think, you have to think in the reverse direction. That is, starting from the starting point must be what they have asked, and slowly write the formula for each one of it. Write the formula for what is asked and see whether you know everything. If you don't know, write a formula for that unknown and keep cascading down till you come to a place where an equation has only one unknown. Okay, as in this case, total volume is not known, so we are writing a formula for total volume. And again, in this case, volume is not known, so we are writing a formula for volume. And now this is a place where we stop because in this equation there is only one unknown. Okay, volume is the only unknown, radius is known, so we can calculate volume. Okay, see, in this equation there are two unknowns. Total volume is what you want to calculate, but you don't know volume, so which means we cannot do it. Similarly here, mass is what you want to calculate, but total volume is not known, so which means we cannot use it. Okay, so you have to cascade down till you come to a point where you can calculate, then go in the opposite direction. So when you think, you have to think in the reverse, that is starting from what you have asked to find. But when you do, you'll have to do it in the direction starting from whatever they have given. Okay, here radius is given, so you're going this way. Okay, that's fine. I've told this many times, this explanation. I hope you all got it right. So let me summarize the steps. Step 1. Substitute the value of r, which is 0.7 centimeter, in V equal to 4 by 3 pi r cubed and calculate the volume of one spherical ball. Okay. Step 2. Calculate the total volume of 200 spherical balls using total volume is volume into number. So volume you have calculated here, number we know it is 200. So these two multiply, you will get the total volume. Step 3. Substitute the value of total volume and density in the equation mass equal to total volume into density. Total volume we have calculated in step 2. Density we know it's given 7.95 grams per centimeter cube. And calculate mass. Please be careful about the units. You check, this is centimeter, this is grams per centimeter cube. So the units are consistent. Sometimes they will give density as kg per meter cubed or whatever. Okay, so you have to make it consistent. The units must be made consistent. Okay, you have to do appropriate conversion and get it into the same units. Here it is fine. Centimeters and grams per centimeter square. So mass will come as grams. Okay, so let me stop here. Now you pause the video and try to work the problem on your own, and after working come back and look at the solution. Okay, here we go, the solution. Given radius equal to 0.7 centimeter, density is 7.95, sorry. Volume V equal to 4 by 3 pi r cube. Substitute 4 by 3 into 22 by 7 into 0.7 into 0.7 into 0.7. So this is 4 into 22, 88, 88 by 3. 0.7 will go 10 times. So 0.7 into 0.7 is 0.49. That divided by this 10 will get you 0.049. When this you multiply and simplify it, you will be able to get 1.437 centimeter cube. This is the volume of one spherical ball. Okay, how many spherical balls? 200. So total volume is volume into number, that is 200 into 1.437. So that gives us 287.46 centimeter cube. Now we know the total volume. The next is mass is given by mass equal to total volume into density. So total volume is 287 and density is 7.95. So 287.46 into 7.95, that gets you 2285.3 grams. But we know 1 kg is 1000 grams. So you'll have to shift the decimal point 3 places. Here, here, here. So it becomes 2.285. That approximately is equal to 2.29 kgs. So the total mass is 2.29 kgs. Okay. I hope you got this problem right. And if not, please check where you have gone wrong and make the appropriate correction. And if you have not understood the concept, please go back to the discussion part of the video and understand the concept clearly. Only when you understand the concept clearly, you will be able to do the problem correctly. Okay? Thanks for watching the video.